Alright, so at this point, Brendan, what do we always do? Everything's separated. We've changed the form by using a method called partial fractions.
Integrate both sides.
Very good. Integrate, integrate, integrate. Alright, so there's a dp now here as well, and a dp there. Alright, so start us on that journey. Go ahead, Brendan. What is the integral of 1 over p dp?
ln of absolute value of p.
Alright, then we have to add to it the integral of 1 over L. Remember, that's just a constant, L, so this is a constant.
Okay.
And so if our u is 1 minus p over L, what's our du, Brendan?
Wait, so p's the variable, right?
Yeah, it is.
P minus... Wait, what did you say?
Do like 1 over
P over
L.
L. Yeah, would it be negative 1 over L or just 1 over L?
Negative 1 over L.
Right here.
Oh, you're taking the
Taking
the derivative there.
The derivative.
Yeah. So wouldn't it just be 1 over L?
Yeah, except what is the sign? See the sign?
Negative.
Right, so this is almost the same except for the sign. So we'll put a negative inside and a negative outside. So we're pulling this to a negative. And then what's the derivative then? If we have, this is our du, Brendan, and this is our u. Now that we fixed it with the negative sign, what is the derivative of that? I mean the integral of that. We've got a u.
Oh, ln of u.
ln of u, and u in
So
this case
ln of 1 minus p over L.
is very good. Are you tracking? It's really not that bad. Alright, so now we're into almost done. We have to integrate this side, so we have k constant, so kt plus c, and over to you. Then Gianni, what's our next step?
You would want to exponentiate both sides.
Right, so when we do that, let's write this using log rules, Gianni. How can I combine that?
It would be p over 1 minus p over L.
Right, and alright, so using log rules, we're exponentiating this and we're exponentiating that. Alright, Morgan, what is e raised to the ln of that?
Just that. The top. P over, yeah.
And what do we get over here?
You would get, wait, what do we, oh, okay.
Exponential.
You would just get KT, right?
No, if there was an ln there, we could. But we do make one adjustment over there. What do we usually do?
Don't we like pull something down?
Yeah, we kind of do. We think of this as e to the kt times e to the c.
Oh, yeah, okay.
And so then what does it become?
So then it becomes, oh man, I forget what you do. Isn't it like,
Because this is just what? E to the c.
C, isn't just C?
It's just a constant.
Okay.
So then the e to the kt, we can't.
Oh,
really-
yeah, okay, I remember.
All right, remember
I just
that
forgot,
step?
yeah.
All right, that happens
It's
a
at the
lot.
top of the board.
Yeah, that happens a lot to us. All right, how are we doing then? We have a good start. Is it possible to solve that for p? That's usually, we like to get p by itself, like up here. Is it possible to get p by itself?
No.
You know what it would be possible though? If we had this on top of the fraction and this on bottom, I think we could do it. Is there any way we could do that? Where's your, if you look at
Can you
back,
just put 1 over c equals k to the
just
t?
flip both sides?
Yeah.
Yeah, and I see an even easier way. Up here, right here, if we had messed with I'm going to go back here and just operate with it to get it to do what I want it to do. And I think what I'm gonna do is, at that point, multiply both sides by -1. So I'm gonna change colors. So that's minus, that's plus, and that's minus, and it doesn't care about that, that's a C. So now, how does that change, who did this side? Johnny, how does that change our answer now? It would be ln of what?
1 minus p over L.
Alright, because it's always the positive one over the negative one, so I'm going to do that. And over here, this is now negative though, so negative kt plus c, so when we exponentiate it, that negative sign is there, and this is upside down for what it was. Alright, now why was I so picky about that? Is because I can now divide these two terms by p, so let's see if that helps. So this becomes 1 over p, and this becomes 1 over, what's p over L divided by p? 1 over,
L.
what did I do to get it together? I did something, and it wasn't that bad. I divide it by, all right, is this right? Oh, okay. Right here,
Tina.
let's put this over a like denominator. Whose turn? I'll take a Morgan. Make that over the same denominator, so what would that look like?
Make that over
I
what?
know.
L, the same denominator, L.
So you'd have to multiply L.
L, I would have to, I can't just multiply by L though, so that's not what I did. What did I do? Somewhere I did that. And follow my own work. Here's what I came up with, see if you can help me get it. It got to the right answer, so I got L minus P over P from this. L minus P over P. Are those algebraically equivalent? I think, see, we can't just multiply that by L. It'd have to be L over L, so L minus P over L.
Miss Powell,
Yeah,
maybe since L is a constant, you multiply both sides by it and the L goes into
yeah,
the
maybe
C.
that's it. I think you're right. I know I did it in one step, and I can't now think of why. All right, so let's do that. Multiply this by L and that by L, and we get L minus P over P, and C e to the minus KT. That was it. Thank you. Very good.
Muy bien, Gianni. Muy bien.
Yes. All right. All right, so now I can mess with this for a little bit, and I think we're about there. We want P by itself.
Sorry, John.
So can I write this as L over P minus 1?
You may not watch it though.
See how I divide L by P and P by P? That's algebra. So now I'm getting very close to getting P by itself. So, whose turn? Aaron, I'll pick on you. All right. I'm trying to get P by itself. So, what do you suggest? Since it's right here. So what do you think I'm going to do with that?
Add the 1 to
Very
the
good. So we move the 1 over here. And now,
Could you just multiply by p and then divide by that entire
yes,
thing?
you're right. So multiply both sides by P and divide both sides by that expression. So we end up with L over C e to the minus KT plus 1 equals P. And believe it or not, that is the solution to this logistic differential equation right here. So we did it. with partial
Yay.
fractions and everything, so.
10 minutes.
Oh no, now we gotta do an example. How much time in the class? Guess we have.
Five.
Wait,
Not very
is that
much.
just how you? Is that like an actual problem that we're gonna get, or is that just the
No, this is
equation?
shoots and ladders, so we
Okay,
started
okay.
with this and we ended down here, so,
Okay.
isn't that nice?
Yeah.
So we did it together, I didn't have to just read it to you, and with your help, thank you all. Let's go ahead and do one very quickly, and you'll have two to do, so that'll be doable. All right, we're gonna release some elk. We're gonna release some elk into the population of a tundra. And let's see what happens to the elk. Here's the problem. 40 elk
40 elk.
are gonna be released. It's into a protected area. In 5 years, guess how many? 104 elk in 5 years. The most that this population can sustain, we understand, is 4,000, so we got a ways to go. 4,000 is our limit. So find how many elk in 15 years. Find elk in 15 years. Alright, so this is the kind of problem that this new logistic differential equation solution can help us. So I'll write it down. P equals L over CE to the minus KT plus 1. So we need to find C and find K, like we always do. Alright, to find C, Brendan, what values do I pick from my box to find C?
The 40,
Right? Equals the limit. What's the limit?
4,000.
We're looking for C and E to the minus K. And
Doesn't K just go to 0?
because we are at time 0 at the beginning
that's
of
what I
this
meant.
problem. So we have K times 0, but then we have a plus 1 floating around in there. All right, algebra. Gianni, solving that, what do you suggest?
Multiply both sides by the denominator and then divide by 40.
Alright, so e to the 0 is just 1, so we have c plus 1 over here, and what's 4,000 divided by 40?
100.
Alright, and finish it off then, Gianni.
C equals 99.
Alright, so we got 99 for c, and I'm just going to erase that because I'm out of room. And
You
I'll
got
go
it,
back up
Johnny?
to here and get the 99 in my equation right here. All right, Morgan, you're going to help us find K.
Okay.
What will go in here?
Would P be 40 again?
No, that's would what P?
Yeah.
No, we're going to use this information.
Oh, okay, okay. So 104,
Uh-huh.
and then equals 4,000.
Yeah, that's the limit. After that, the protected area can't sustain any more elk.
Yep, and then 99 over 99e times negative 5, or negative k times 5.
All right. All right, do you see
Plus-
where I put a T? The T took on the 5.
Mm-hmm.
All right. All
Plus
right,
one.
Aaron, algebra.
Go in. Morning, Ewan.
Okay, so you can multiply the entire denominator
Uh-huh.
and then divide by 104.
All right, could you get 4,000 divided by 104?
It is 38.4615.
38 point? Is that what
Yep,
you said?
yep.
Okay. All right, we'll go with it. So, keep doing your
And
algebra.
then you subtract 1.
And so that becomes 37.
Yep. And then
And,
divide by 99.
all right, what do you get?
4. Did I say 4615? 0.3784.
I need more room. Goodbye. That's a 3-minute warning. No, we're gonna make it.
Miss Powell, we're at 15 minutes for this video.
Close it up. We can't go any further than that.
Alright.
Jeepers.